start, and this is going to cover 7.2 and 7.3 parallelograms. You've probably already done work on this, at least if it's this year. But I'm going to kind of go over the basics. We're going to do this over each shape, especially in the parallelogram family. So we're going to learn about parallelograms first, and then in the family is, of course, rhombus, rectangle, and square. So we will get there. So I'm just going to go over the basics here, and so I'm going to turn this off. Okay, and so you've already written down the theorems, so I'm not going to rewrite them because that's easy. So we need to come up with the basics that we need to know on parallelograms. Okay, so the definition is opposite sides parallel. Okay, we know that. We know that opposite sides are congruent. And I'm going to come up and mark the shape. Sides are congruent. I'm actually going to make this bigger and less basic. So opposite sides are congruent. Okay. Opposite angles are congruent. Okay, just to mark that real quick, of course, opposite sides, bam, 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 bam. Opposite angles. Well, I should use the same color, huh? Bam, bam. Bam, 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 bam. Of course, opposite sides parallel. I did mark that. That's something you've known. Okay, moving on to the different theorems. Of course, one of the theorems basically states that since these are congruent, that if I add this plus this, they equal 180. Okay, and we're used to that with parallel things. Okay, congruent, equal 180. So that's how you set up some of your problems. Okay, and then here's where it kind of gets different. The diagonals, and this is what's going to be different from what you've done in the past for sure, and something that kind of defines the various shapes. So, and this could be difficult on your homework as well. So essentially, this and this are equal, and this and this are equal. So basically, in a quadrilateral, is a parallelogram that its diagonals bisect each other. So that's, remember, definition of bisect creates two congruent sides. So let's just write that in red. Diagonals. And so each shape will deal with diagonals. Okay. All right, that's basically all of the theorems here. Okay, and I'm going to move on to 7.3. I'm going to move, I don't want to do that. I'm going to move on to 7.3 here. And go over those theorems, and then I'm going to go help you with a couple of the problems. Okay, so 7.3, you're going to need to write down those theorems in your notes. I'm not going to do those. I'm going to let you do that, but I'm going to go over it. It's basically proving parallelograms, proving that a shape is a parallelogram. So we're not going to do a formal proof, but we are going to need to know some of these qualities of things. Okay, and there's a really good summary of it after you write down your notes, but it does have parallelogram opposite angle converse and parallelogram opposite sides converse. So basically, opposite sides, opposite angles, the converse is also true. Okay. In your book, I really like this right here. It kind of puts all of your stuff and things. Let's get it all nice and right there. This is page 343. That's so crooked. There we go. So this basically covers all the different things that help you prove things, how you can prove it. Okay, show the diagonals bisect each other, show that one pair of opposite sides are congruent, and parallel also works. Okay, and these are different ways to do it. Okay. And then these also are different theorems, because on 342 there's two more theorems. The opposite side parallel and congruent theorem, which is basically this one, and then the parallel diagonals converse, which is this one. Okay, so these are basically the theorems, and this is a good little list of things, and it cuts it down to the basics. Okay, so we're going to go over some problems and see how we did. I did have some requests for a little bit of confusion. Of course, when you're using the computer program, if that's what you're doing, it is a little confusing, especially when it doesn't tell you exactly what it wants. All right, so I'm going to start with 7.2, and if that's not what you need, I'll write a big 7.3. I'll write a big 7.3 when we cover that. Most people are okay with this to a point. Let's just look at the strategies, and I'm just going to talk about the strategies. So here, you usually find the value of each variable in a parallelogram. Remember, just look at those different theorems that you have, the different rules. Opposite sides are congruent, so x would equal 9, y would equal 15. Okay, opposite angles are congruent as well. So you just set these, 105 equals d minus 21. Okay. Usually, people are okay with that. Okay. Measure B. On 7, remember opposite sides are equal. So that's 51, that's 51. We have a theorem that says that's 51, and that is, well, I don't know. So angle B plus 51 equals 180 is what the theorem states. This is usually where people get confused when we have, well, and I like doing this as a book better than doing it in the computer just because you can see I need to do all these things. So just remember, and so I'm going to kind of work this out just a little bit for people that need it. So I'm going to freehand this and see if it works. And I'll try to make it ish. Okay, and again, I like to do, I don't like to have to do it one at a time, but they make me, so that's fine. Okay, so one thing that it says, this whole thing is 100 degrees. So not cut in half, the whole thing is 100 degrees. Just this little line is 7. Okay, just this is 8.2. Of course, my picture's terrible. I can't handle it. It's too bad. It's better not to freehand it, as I just proved. Because it just looks off. And this is technically still freehanding it, but with a straight edge. All right, that looks better. So just what I know is this would be 7, this would be 7, this would be 8.2, this would be 8.2, this whole thing would be 100, this whole thing would be 100. Okay. This would be 80, and this would be 80. How do I know that? 80 plus 100 is 180. And so they need to equal each other. How do I know this is 7 and this is 7? Because diagonals bisect each other. Okay? So I'm going a little more detail with this just because, well, you should have already tried it. Okay? I know that this is 13, and this is 13, this is 8, and this is 8. This is 29 degrees, but I thought you said it was 80. Just the small one's 29. Okay, so if this is 29, I can find out what the other one is, because that would be a 51, because 51 plus 29 would equal 80. Okay, and then alternate interior angles. That's 29 up here, which would make this 51. I don't know if I need any of this stuff, but probably I do. And so then you can just go through this list, like number 9 is LM. L, M, N, Q. So now I can just look at my shape. Now I can just look at my shape and I can fill in the blanks. Well, LM is 13. LP. What's LP? Well, LP is right here. Oh, I just filled in a 7, right? That's P. So that's basically how you do that. That's usually where people have problems. Moving on to the next set. If I need to do this in more detail, we can do it back in class, but I just wanted to give you hints on how to do these problems. But definitely draw the shape even if it's on the computer. Definitely draw the shape even if it's on the computer, because that is so much easier just to fill things out. Okay, find the value of each variable, like on number 17. It's basically two problems. 2m equals 70, and n plus 70 equals 180. It's kind of how you fill that out. And then moving on to the next one, like 19 and 20. Okay, and I'm giving the book numbers. This would be like k plus 4 equals 11. It would be like m equals 8. 20 would be like 2u plus 2 equals 5u minus 10. And 6 equals v over 3. So that's basically that section. Hopefully that helps you out. I do think, was it this section? I don't think it was this page. There's one answer that was just obnoxious that the book gives, but that was another page where you had to do 88 and 1/3 instead of 88.3 or something like that. Moving on. So this is the new stuff that we're doing today. And so I said that I was going to put a big... Uh-oh, I'm out of paper. This notebook is done. So that's not good. 7.3. So hopefully we can scan ahead to 7.3. I'll put a note on here, 1250. It's not really for the video, but 1250 is where 7.3 help starts. And that's for me later. So 7.3, it's going to be in the computer again, but I'm going to call it page 345 if you want to look at it. I do like the computer helps better. Okay, so state which theorem you can show that the quadrilateral is a parallelogram. So it should be pretty easy. This is 3. I'm going to look at it, and I'm probably not even going to write it down. Just look at it. Well, which theorem? Well, I did say that there was that great section in the back. And because I don't need to know the number of the theorem, but the great section in the back here, let me see if I can show that right here. That's going to tell me. So the first one, I'm going to say, well, opposite angles are equal. I'm just jerking around the camera here. There we go, back to focused. Opposites are equal. And so that would be the parallelogram opposite angles converse. Okay, that's what we're using to prove it. So just use those 5 choices. So use one of those 5 choices on here. All right. Moving on to 9. Find the values of x and y that make the quadrilateral parallelogram. Well, that's where the opposites are equal, right? Okay. Same thing with 11 and 12. Opposites are equal. That's what it's about. And right here, those are going to be equal. Opposites equal, opposite equal, all that kind of stuff. And that's really what you're doing tomorrow. So not a lot, not that difficult. So don't make it difficult. Okay. So I might throw in a couple fun ones. Just make sure you look at, probably not honestly since you're at home. Just make sure you look at your stuff and let's get done. And then before we go back to school, we're going to do 7.4, and so there'll be a video on that. So you can kind of look forward to it. And that's going to be right here. All about parallelograms, rhombuses, squares, and rectangles. So that's what we're going to do. So, until next time, see ya. Bye.